Alright, this is Nick again, and I'm back with continuation of this video series on the relationship between distance or location and time graphs. We continue to talk about graphs in this series. Okay, we're still in part one. The only difference in this one is condition 2, although condition 2 should have been mentioned in the previous video, because that condition, what was added to the condition was the fact that in at least one example, I did mention or show how the direction could be negative. Okay, the whole aspect of being negative uh, came into play. All right, and also how the velocity can be considered to be negative also. So here we go with another video. This is the third video in the series. So we are looking at this graph. A little. Alright, so this is the graph in which we have the object is obviously moving from zero at and it's constantly changes its distance with respect to time, which means that it has a constant velocity, right? And then it turns around and comes back. Now this is where the negative distance will come in, meaning that it's going back to the left. Negative means that it's going back to the left. Positive means that it's going to the right. Negative means that it's going to the left. However, in this case, it just stops abruptly, but the distance is decreasing. That's different, because you would notice that the time has remained at 2. Okay. The object is moving away from the point of origin, and then it returns to the point of origin. The object's velocity is constant in the first part. It becomes nothing. Yeah, this is nothing. This shows nothing. The displacement, then is in this particular case, the displacement is 0 because the object starts from here and comes back here. So the displacement is 0. The distance is not 0. The distance would be twice the distance from here to here, okay, because it came back. Okay, remember, the distance is not negative, only displacement that is negative. The velocity starts out to be positive and then it becomes 0. Acceleration is 0 throughout the entire section. In the first part, the acceleration is 0 because the velocity is constant. And the second place, acceleration is 0 because velocity does not really exist. Alright? The slope is the velocity. The slope is positive at first, and then it becomes 0. It becomes nothing, really. It's not even 0, it's nothing. Well, I guess you could call that 0. And this is the equation. Y is equal to kx, and then y is and 0 is equal to 0 times, alright, yeah, because the slope is 0, and then the y value would be 0. So okay, let's move on to the other one. Well, this is the same thing. It might look a little complicated, but it's the same thing. Starts at 0, goes up, comes back to 0. Right? Starts at 0, goes up, comes back to 0. So it's just repeating the same thing. The only thing that changes here is really the time. Alright? The time continues, as it keeps going up and, well, goes up, and so nothing really changes here except the fact that it is going through the time. We have from 1 to 2 and then from 2 to 4. Incidentally, Note that in this particular graph I've had some improvement from the last video, because now I have 1, 2, 3, 4 and 1, 2, 3, 4 going in this direction. Now I have not designated the 1, 2, 3, 4 as being anything. So when I say time 1 or time 2, it could be seconds, it could be months, it could be years. So I'm just gonna call them time 1 or time 2. Same thing with distance. I'm not specifying whether it's milliliters, millimeters, centimeters, meters, or kilometers. I'm just saying that. Okay. All right. So that's the same. This one is a little different. Object starts from zero distance, zero distance. This is zero distance. Okay, zero distance. But it didn't start from time 0. So at some journey, at some point in the journey, it starts to move. When it moves, it's moving at a constant velocity, right? Well, yes, the velocity is constant because the distance is changing constantly, with respect to the time. Object starts to move away at time 1, right? And it just continues, right? The acceleration is 0 because the velocity is constant. All right. Both the displacement and the distance are positive. Velocity is positive. I mentioned that the acceleration is 0. Okay, the slope is positive, and y is equal to kx. Y is equal to k times x, not negative or not 0. Okay. This is the same thing. The same thing. It's just that in this case, it is starting from a particular distance that is not 0. Starting from a particular distance that is not 0, and it is velocity is constantly changing. The constant velocity. Of course, that means that the acceleration throughout the time is going to be 0. Let me just change this to I'm trying to avoid putting the letters 0 or the word 0, so that we can be somewhat consistent. All right. Again, the velocity is positive. There's no proportional relationship, direct proportional relationship here, because even though we have a straight line, the straight line does not go through the origin 0, 0. So therefore, it means that it is not. There isn't a direct correlation of direct proportion. Sorry, not correlation, proportion. Thinking more statistics. All right. Now this one, well, the first thing I want to mention is that this is supposed to be connected. So that is not significant. The fact that there's a space here is not significant. All right. So object is at a distance 3, and is not moving until time 2. Then it moves down towards to at time 2, reaching a distance of 2. I don't know how that is going to be possible. How he's going to move from 3 to 2 without any changing time. So you got to be very careful there. Time must elapse. Time must elapse when you are changing distance. In this case, there's no time. But that tells us something. Then at time 2, it stops again. There's no distance. The distance remains the same. All right. Remember that for velocity to be present, both the distance and the time must be present. Right? Because velocity is the change in distance divided by time. If time or velocity or distance, if any one of them is 0, then the velocity is going to be 0 here and here. Of course, if the velocity is 0, the acceleration is 0. All right. Here we go. Velocity is 0. Velocity is positive and is 0. There isn't any direct proportional relationship, and y is equal to 0 times x. Y is equal to 0 times x. there, here, here, and here. Okay. All right. In this next one, we have object is at a distance 1. No, our object is at a distance 1, right, and moves away. Moving away meaning moving to the right, at a constant velocity to distance 2. This distance 2 after time 1. In other words, by time 1, it has reached distance 2. Now that makes sense, although this one should be a little bit more more here. No, actually, no, a little after time 1, a little after time 1. That's correct. All right, object velocity is constant throughout. You see, constant throughout. So what happens when the object reaches here? When the object reaches here, the object turns around and begins to go left. Right? Begins to go left. Here, the object reaches 0, which is the point of origin. Although the point of origin of this for this particular object is actually 1, not 0. But when we say point of origin, I'm talking about here, right? So the object starts at this distance, right, and then comes back to that distance. So at around two time, it's about where it began. Then it continues to go left until it reaches 0 distance. Then it continues to go left again. Now in this case, again, the distance continues to be positive because distance is scalar, but the displacement, which is a vector, is going to be negative. It's not going to be 0, but it's going to be negative. Okay, at this point. Okay, velocity is constant throughout. It's just the velocity is going to be negative. Right, the velocity is going to be negative. First, the velocity is positive. Right, the velocity is positive, and then the velocity changes to be negative. Because remember, velocity is a scalar quantity, and it can be negative. No proportional relationship, and y is equal to the scale, the gradient, k times x. Now this one is sort of a makeup one because I had to go back to the original diagram, the original graph. So you just imagine that I have the 1, 2, 3, 4 on the 1, 2, 3, 4. But in this case, what is most important in this case is that the velocity, the object is starting from the left. You see, the object is starting from the left. From here to here, the object is starting from the left of the origin, from the left of 0 distance. Remember, this is a distance time curve. Gotta be very careful here. Object is starting from the left, and then it gets to 0, and then it turns around. Well, not turns around, but it is now going to the right. Object is going to the right, right? So the object starts from the left of 0, then gets to 0, and then continues to the right. Notice that nothing changes in the velocity. Nothing changes in the velocity. The velocity is constantly positive. Constantly positive. The only thing is that there is a difference in the distance. Difference in the distance. Okay. Now, had this been a velocity time graph, then the interpretation would have been different. Okay. All right. I think that we covered quite a lot in this video. I am not too sure exactly what the next video will be yet because I want to do one with only the slope, but I also want to get into the whole aspect of curves. What happens? What happens if you have a curve in still the distance time graph? What happens if you have a curve? Because we haven't touched on the curve yet, so I will make a decision and see which one I do next. Thank you very much. Again, this is Nick. Until next time.